Hi, my name is Deborah Kitzler, and this is my lab report for the 5th lab in Physics 2211. In this lab, we were given the task to choose our own adventure, and I chose to investigate the motion of a falling slinky, specifically the bottom of the slinky when it is dropped from a position in which it is fully elongated. I utilized position data obtained from this given video in the tracker program to produce my observed data, and then I used GlowScript in order to create a prediction model of the falling slinky. And then I compared the observed versus predicted information, as we have done in previous labs. The principles I used mainly were Newton's second law, which states that the final velocity is equal to the initial velocity plus net force divided by the mass times a change in time. The forces that I considered to be acting on the bottom of the slinky were the force of gravity, the drag force, or air resistance, and the force of tension on the slinky. The force of tension and the force of drag both acted in the upward direction towards the hand that was holding the top of the slinky initially, whereas the force of gravity acted in the negative direction. As you can see, force of gravity and force of tension were both equal to mg in their respective directions, and the force of drag was equal to a constant, b, times the magnitude of the velocity squared. This is the tracker video that I used. I set the coordinate axis to be at the origin to be at the hand of the man dropping. I then tracked the position of the bottom of the slinky as the slinky was dropped. I used the initial conditions that the mass of the slinky were approximately 0.225 kilograms, which I got this data from Google. I tracked the bottom of the slinky, so the initial position of the bottom was 0.0286 and negative 1.228. And this I got from Tracker and inputted this into my GlowScript code. I said the initial velocity was 0 as the slinky was initially dropped from rest, and the change in time was 0.04 seconds. As you can see, the value for B, which is the proportionality constant used in drag force, I estimated to be 0.000025 in order to get as close to my final position as possible. As you can see, I used two different while loops. I used one when the timestamp was less than 0.32, and in this I said that the only forces were to consider acting on the bottom of the slinky were the force of gravity and the force of tension. However, at the timestamp 0.32, the slinky had fully contracted and there was no longer a force of tension acting upon the bottom of the slinky, and so the two forces acting on the slinky at this point were the force of gravity and the force of drag, so I used those two forces in my second while loop. And both of these use Newton's second law and momentum principle to determine the change of velocity, the new velocity, and the new position. As you can see, I received a position versus time graph as well as a velocity versus time graph that seemed to make sense and were very similar to my observed data. Now, the observed data shows the bottom of the slinky moving upwards briefly before falling down. This could be due to human error while using tracker or unaccounted forces, perhaps wind, or perhaps the man's hand was moving slightly. The B value I used to receive this data was 0.000025, which is very, very small. And as you can see, the end positions differ slightly. However, this is because the predicted data might be due to human error, or as I said again, there are unaccounted forces that I did not input into my GlowScript code. So now we can ask our question, does the bottom of the slinky move? As we observe, the bottom of the slinky does not move while the forces acting on it were only tension and the force of gravity. This is because the magnitude of the force of tension is equal to the magnitude of the force of gravity, and they're acting in opposite positions. This would indicate that the net force acting on the bottom of the slinky at this point in time while the slinky was still elongated would be 0, and therefore the velocity is not changing and the slinky is not moving. However, once the slinky has fully contracted and there's no longer a force of tension acting on the slinky, the bottom of the slinky will begin to move. The entire slinky is now one point and it will move downwards as the force of gravity acting downwards is larger than the force of drag that is acting upwards. Thank you.